Okay, coming right off of the T helper 1 response, let's talk a little bit about the T helper 2 response. So remember, we have this initial starting point here where we have some antigen presenting cell presenting an antigen to a naive T cell, right? A cell that hasn't been exposed to this antigen before. And there's a lot of different ways we can go by communicating with that cell using different cytokines, for example, okay? And we already talked about, look, if we go down the T helper 1 pathway, that macrophage or that dendritic cell potentially will release interleukin 12, sending me down a T helper 1 pathway, which will ultimately result in interferon gamma being released from that T helper 1 cell to then activate that macrophage, activate CD8 positive T cells, and potentially natural killer cells. CD8 positive T cells, again, think cell-mediated immunity. You're going after cells to attack them, essentially going after cells that have MHC1 that are infected. Okay, so that's the process of interferon gamma. And remember, this interleukin 12 is very classic for stimulating this pathway to lead to macrophage activation, epithelioid macrophages, and giant cells in the setting of a granuloma. And we talked about that in great detail. So that's this first pathway that we just talked about. Now, if we look at interleukin 4 here, this is going to take us down the pathway of the T helper 2 pathway. Okay, and again, this is humoral mediated. When we say humoral mediated, what are we talking about? We're talking about primarily B cells, okay, and more specifically, we're talking about plasma cells. And remember what I said about plasma cells. Plasma cells are essentially like antibody factories. So high levels of antibodies is going to be pretty much associated with this humoral immunity. Okay? So you can see here, interleukin 4, interleukin 5, interleukin 9, interleukin 10, and interleukin 13 all going to be very classic for this pathway. You might be saying, well, why? Why are those cytokines so specific to the T helper 2 response? And it goes right into this next segment here. So remember, this dendritic cell is then going to send interleukin 4 over to this naive T cell, and in doing that, will stimulate this T cell to become a T helper 2 cell. That's step number 1. It's a CD4 positive T cell here, right? CD4 positive binding to this antigen presenting cells MHC2, right? Because antigen presenting cells usually are going to be using their MHC2 to express antigens to CD4 positive T cells, and then stimulating a cascade. 2 times 4 is 8. Remember your rule of 8s. So then this naive T cell is going to get stimulated with interleukin 4 to go down the T helper 2 pathway. T helper 2 cells will then go on to release specific cytokines. Okay, cytokines that include interleukin 4, interleukin 5, interleukin 13. And we're just going to say that we have some antigen presenting cell here. It's got MHC2. It's got an antigen on it. Remember, MHC2, it would have to be for it to bind to a T cell. And then let's just say that we have some T cell here. Okay, it's going to be a CD4 positive T cell. All right, and this T cell is going to be naive, right? It hasn't bound to its antigen, okay? And let's just say it has a T cell receptor right here, okay? And that T cell receptor just so happens to be a perfect fit for that antigen. So these two are going to bind, right? And then what's going to happen is this T cell will then get activated, okay? It will get activated. And when this T cell gets activated, now what can happen is the antigen presenting cell can send over a signal. We talked about in the T helper 1 response, this can be interleukin 12. Okay, but it can also be, right, it can also send some cytokines over that are interleukin 4. If it sends interleukin 4 over, it's going to turn this into a T helper 2 cell. And let's just say that we have some B cell here. And remember what I told you in the beginning, B cells can also bind antigens, right? So this B cell might have the same antigen that this antigen presenting cell had. And that can also bind to this T helper 2 cell. Okay, so when this happens, the B cell can also become activated. So the T cell is going to have a CD40 ligand receptor, and the B cell will have a CD40 receptor, okay? And this CD40 ligand binding is going to cause this B cell receptor carrying the antigen binding to this T cell receptor, right? It's going to cause this link up to eventually lead to this B cell undergoing class switching and potentially forming a plasma cell, potentially, okay, and undergoing class switching. And the thing that helps assist with this class switching process to go from a B cell that's primarily releasing IgM to a B cell that then releases some of these other antibodies with class switching is going to be this CD40 ligand linkage. And I'm getting a little off track because we'll talk about this in another video, but that's really this whole kind of process from start to finish. Again, started with an antigen presenting cell, sent interleukin 4 over to the T cell, caused it to become a T helper 2 cell. That T helper 2 cell can then run into a B cell that also is presenting this antigen. It can link up CD40 ligand and cause this B cell to develop class switching, IgG, which would be great for a memory response. If we wanted an IgE production, right, then the T helper 2 cell might release more interleukin 4 to this B cell. So it might send more interleukin 4 to the B cell. If it did that, we would get more IgE production. Okay, that would cause more IgE. Now, if instead the T cell sent interleukin 5, right, to this B cell, so let's just say instead it sent interleukin 5. So if it sent interleukin 5 to this B cell, then this B cell might produce IgA, for example. Okay, so that's where these interleukins come in. The initial interleukin 4 is largely driven by the antigen presenting cell sending it to this T cell, CD4 positive T cell, causing it to become T helper 2. This interleukin 4 is being sent to the B cell to cause that B cell to basically become a plasma cell, an antibody factory for IgE, right? As opposed to if we use interleukin 5, then becoming a factory for IgA. And interleukin 13 also has a similar effect to interleukin 4 in that it causes increases in IgE. Also remember, this sometimes gets looked over. IgG, which is probably the most common antibody that we talk about, also is coming from this interleukin 4 response being sent to the B cell to switch, to class switch the heavy chain from IgM to IgG or IgE. Okay, so now if you're thinking about parasitic and allergic responses, it's also important to remember that interleukin 4, 5, 10, 13, 17, all very classic for those responses, which, I mean, it makes a lot of sense here. I mean, especially in an allergic response, right? You're thinking interleukin 4, interleukin 13. Why? Because IgE response, right? IgE is going to be very classic for the allergic responses in general. They're going to be binding to mast cells, for example, causing degranulation. And then interleukin 5, you might be saying, well, how is that related to an allergic response? Remember, interleukin 5 also causes upregulation of eosinophils. Okay, so eosinophils are also very classic in these responses. And you can also see that here, right? So interleukin 2, we already talked about it being kind of more nonspecific. The antigen presentation really driving this interaction to cause this naive CD4 positive T cell to go down to the T helper 2 route. So think of interleukin 4 kind of as the interleukin 12 equivalent of the T helper 2 response. Okay, and the last thing I want to talk about on here is going to be the Tregs and the T helper 17 response. And we're not going to go into too much detail on this. We're just talking high yield, high level overview. So think of TGF beta as the most high yield cytokine to remember when you're talking about a decrease in this immune response. If the immune response gets out of control, if it gets too high and you start attacking your own cells, you have some autoimmunity, the Tregs are essentially going to come in to control things, to get things to step down. And they're going to do that through the release of TGF beta. That's the most important cytokine to remember. The next most important will be interleukin 10. These are going to stimulate Treg development, which are essentially, like we said, going to prevent autoimmunity. You can imagine if you don't have these regulatory T cells or these Tregs, then you're at higher risk for autoimmune reactions because you don't have the cells that prevent autoimmunity, right? And then also this TGF beta will also be involved with the T helper 17 response, which is why I kind of include them here. T helper 17, it's pretty straightforward. It's going to classically be associated with interleukin 17, and these are mostly related to neutrophil function. We don't have to go into all the details on that. That's, pretty much the extent of it. So again, you can see here, TGF beta kind of being the classic molecule to remember when we're thinking about T helper 17 expression versus Tregs, but interleukin 10, much more specific for bringing down that immune response. And the way to really differentiate these two, again, interleukin 10 more associated with the kind of decreasing the immune response altogether, whereas when you're thinking about the T helper 17 response and neutrophils, you're thinking more about interleukin 17. And so that's kind of an easy way to distinguish both of these, even though they both involve TGF beta.